This is a universal statement. Now let's talk about how to prove a universal statement is true. So how can we prove a universal statement? Whoa, look at that, earthquake. How can we prove a universal statement is true? What do you think? So again, remember a universal statement, this is the statement for all x and d. P of x is true.
Would we have to
prove
like,
this is
each
true?
Individual thing in the domain to be true?
Yeah, exactly. To show true, for all x and d, p of x, this is a statement, right? So it has a truth value. To show this is true, must show that for each individual x and d, p of x is true. That's what it means, right? i.e., so if you show that each individual x and d is something you can plug into the predicate and make it true, what's another way to think about a universal statement being true? And maybe I'll point to something pink on the screen.
Use a truth set.
Exactly, Safa. Use a truth set. If we're saying this statement is true, so we're saying that for each individual x and d, p of x is true, what's that mean about the truth set of p with this domain?
They're equal.
Equal to what?
The truth set is equal to the domain.
Exactly. Right? Exactly. Thank you, Alex. Exactly. You saved me words. You saved me having to say that. Instead of just dumbfounded, I just say more words than I would before. Yes, exactly. Right? We're saying for all x and d, p of x is true. What that means is that, the set of all x and d that makes p of x true is the entire set d. Every x and d makes p of x true. So the set of all x and d such that p of x is all of d. So, i.e., the truth set of p of x with domain D is D. We're going to say equals D. And we'll go over some set notation later, but the reason we can use equals is because I'm saying this set is a set of things is equal to this set, meaning everything in this set is in D, anything in the truth set's in D, anything in D is in the truth set. But anyway, yeah, it's just saying it works for everything. So just to keep this definition up for a second, I'll let the universal side encroach on the existential side. And let's do an example. So an example of this would be for all x in my left sock and right sock, right? X is white. So by the way, in English, because in real life we're going to translate these. In English, this means all my socks are white. Or all the socks I'm wearing are white, right? So all my socks are white, but in math we're saying this is a universal statement. We're saying for all x in the domain of socks, the predicate x is white is true. All right, so how can we prove that? Well, my left sock is white. Left sock is white, check. And right sock is white. Right sock is white, check. Thus, the truth set of, this is where we have to kind of label things. Let's just call this S of X. The truth set of S of X with domain left sock, right sock, equals, remember the truth set is all things you play to make it true, right? And we know that left sock makes it, left sock is white, that's true. Right sock is white, that's true. So this equals left sock and white sock. Looking back on it, really just labeled left and right. Now left sock, right sock would have saved about 17 socks. There we go. Left sock, right sock. Therefore, for all x in left, right, S of X is true. So, very simple example. This is just how you prove that a universal statement is true. You go through the domain and you check everything in the domain. You show that if you plug it in the predicate, it makes the predicate true, right? So left sock is white. So left sock is white. What this is saying, this right here is really saying that like S of left equals true. This is like S of right equals true, right? So we showed that for everything in the domain, it makes the predicate true. So then the truth set is going to equal everything in the domain, which is what it means for the universal statement to be true. Any questions on that?
Is there like a standard name for the truth set itself? Like in this case, like S sub T or something like that?
Oh, no. Sadly, not that, in my experience, it's not a standard one anyone really uses. It's one of the few things in math we actually write out for the most part. However, we're going to kind of quickly abandon the truth set and just say it's under the hood, but not actually show it. So you'll have to write it a little bit.
Okay.
Yeah. Make sense? It's like one of those particles that like physics particles that shows up real quick to make the math work and then it leaves. One of those things. But yeah. So this is an example of a universal quantifier. Clock in this room? How are we doing on time? Oh, we're doing fine. So let's do another example. Any requests? No, you guys trust me as math DJ? Okay. Well, the next up, folks, we got a slow one. that is for all x. Actually, this is a different variable because the variable doesn't matter. For all n in the set 3, 6, 21, n is a multiple of 3. All right. So proof. So we're to prove a universal statement, we're going to have to show that n is a multiple of 3, which is the predicate. What should we name it?
M sub 3.
Like this?
Well, I said M as in like multiple, as in
Oh, I
narrowing
like that. I like that. Good, good. Oh, I like that. I like that. Let's call it big M, not to confuse anybody. But yeah, let's call this big M of n. So n's what you plug in, big M. I like it. Good. So for all n in 3, 6, 21, that's set, is multiple of 3. What we're really saying is that for all n in this domain, M of n is true. So proof. I'll say notice. I don't know if you hear my computer fan's going off. There's not some kind of explosion. So notice that 3 equals 3 times 1. So 3 is a multiple of 3, i.e. M of 3. Further, 6 equals 2 times 3. So 6 is multiple of 3, meaning M6 is true. And then finally, 21 equals, actually, I'll write this 3 times 2. It doesn't really matter. 21 equals 3 times 7. So M of 21 equals true. So being a multiple of 3, right, that just means you're some number times 3, some integer times 3. We're going to go through these definitions later. We're kind of being a little wishy-washy here with the multiple, but we're not being wishy-washy with the universal statement. So the point is, right now we've shown that for every n in the domain, for every n in the domain you plug in, M of n is true. Thus, the truth set of M with domain 3, 6, 21, that's going to equal, well, you plug 3 in, it's true. M of 3 is true, M of 6 is true, and M of 21 is true. So the truth set is 3, 6, 21. Therefore, for all n in 3, 6, 21, M of n. Super simple, right? Any question on this? I mean, I should say why, right? So all we're doing is showing that the truth set equals the whole domain, and this is just real and simple. We're just going through everything in the domain and literally exhausting the possibilities, which is why oh no, I dropped the green markers perfectly. So there we go. Which is why okay, green marker doesn't work anymore. We'll use maybe orange. This is called method of exhaustion. So going through and checking literally every possibility in your domain is called the method of exhaustion. There we go. Any questions on the method of exhaustion? Pretty simple, right? Good, good. Now, before we get too confident and too cocky, let's note one thing. What if my set here was an infinite set? What if instead of 3, 6, 21, my set was like, what if it was all multiples of 6? Multiples of 6. Can you use the method of exhaustion on this?
Probably not.
You're sensing not based on my tone, right? Let me ask you again, put a poker face on. Can you use the method of exhaustion on this? Was that, I feel like I'm still on tone. Oh, the point is, what would go wrong if you tried to go through? So let's see, the first multiple of 6 is 6. The next one's 12. The next one's 18. So you check it for 18. Check it for 21. Check it for, or 21's not one. Check it for 24. Check it for 30. Check it for 36. Check it for 42. What issue are you going to run into here?
You can always keep going.
Yeah, there's infinitely many things to check. So if your domain is infinite, the method of exhaustion won't work. And to get to how to prove that is for a later lecture. So stay tuned. But the point is, this is a good start. Right, we have a start, right? For finite things, which right now seems like a reasonable thing to talk about. I mean, after all, everything in the universe that we know about is finite. Anytime we have a singularity, we assume it's false. Anyway, the point is, for finite things, method of exhaustion will totally work. It might be exhausting, but it will work. That's not even a pun. That's just, I mean, it is kind of a pun. That's why it's called the method of exhaustion. But anyway, kind of. Exhaust and exhaustion, they share a common ancestor. So yeah, so that's how you prove a universal statement's true.